These are the notes for pressure. The key questions for this unit are: what is pressure? How is pressure calculated? What is the SI unit for pressure? How do force and surface area affect pressure? How does pressure change as you go up in altitude or underwater? And what types of things happen as air pressure changes? During these notes, I also want you to make sure you write down the answers to a lot of the questions, and also any other instructions I give you, so I know you're listening and paying attention to this entire set of notes. These are the words to know: pressure, weight, surface area, altitude, vacuum chamber, Pascal, vacuum, increase, decrease. Be sure you circle Pascal, because this is a new metric unit that you're going to need to know. So circle that right now. So what is pressure? Pressure is force per unit area. It is a measure of how spread out a force is. So we know what a force is. That's a push or a pull. And we're mainly going to be thinking about pushing. So let's consider some different things that can happen when we push on certain areas. Now you should remember what force is, and you're familiar with it. All right, if we're pushing on something, we're applying some force to it. But let's think about what area means. Area is just the surface that something covers. And if it's a regular, like rectangular square, we can just do length times width, and we can figure out what the area is. This area is smaller than, say, this area, which is smaller than this area. So when we think about surface area, or just area in general, we're thinking of how much coverage, or how much it's covering. So smaller areas, and there are larger areas. And when we talk about force being spread out, we can think of a force being spread out over a small area, or the same force being over a large area. And if we look at each of these, maybe we have 5 newtons on each one of these, we have to think of this in terms of pressure, because each of these would have a different effect. There would be a different observation depending on which one of these had the 5 newtons acting on it. Now we can calculate pressure using that force and area, and help us think about what happens to pressure as we change force and area. Pressure is equal to force divided by area. And when we do force in newtons divided by area, a meter squared, we end up with 1 Pascal. And remember, this is meters squared because we're going to do length times width, or any kind of measurement, and if we do that, right, we're going to end up with a value being squared. Right, this means area. And we'll abbreviate the Pascal to PA, just like we abbreviate Newton to N. Right, we have an abbreviation for it. Let's look at these questions and see if we can answer them using this equation. 40 newtons of force is pushing on 2 meters squared. What is the pressure? Well, first we write down our equation. Pressure equals force divided by area. And then we plug in our numbers. Our force is in newtons. That's going to be 40. And area, 2 meters. 40 divided by 2 is 20. And this is Newton meters, so we know this is going to be pascals. Okay, that's our answer. Try to figure out this one, the next one, on your own. Okay, for this next one, we have a block with a weight of 6 newtons. And it's on the ground, All right, and I can just draw some ground here. All right, it's just sitting here on the ground. All right, what is its pressure going to be? Hopefully you've calculated this out. First thing you did was you put the equation down here. And then you filled in the force, which was 6 newtons, area 0.5 meters squared. 6 divided by 0.5, that's going to be 12 pascals. So now you know how to solve for pressure using force and area. But what does that really mean? Being able to calculate it's useful. We want a more intuitive way of thinking about pressure. We just want to know what happens when we increase or decrease force and surface area. So this is the gist right here. And you can show this mathematically as well. As force increases, pressure increases. That makes sense. We push harder, there's more pressure. As surface area increases, pressure decreases. And as surface area decreases, pressure increases. We can think back to the example we had earlier. If we have different areas, but we have the same amount of force on each one, let's say in this case we'll say we have 4 newtons on each one of these, which one is going to have the greater pressure? The one with the smaller area. We have all of this force in a smaller area, we're going to have greater pressure. If we spread out that force, each piece of this area is getting less of that force. So it's spread out over that greater area. Less of it is being in any one place. So we've spread out that force in a greater area. So the greater the area, the less pressure there is for the same force. Let's look at these next questions. Which of these will have more pressure? Go ahead and take a guess. Circle the one you think is the right answer. Make sure you do the calculations to figure it out. If you think you get this so far, put a little star in the corner over here by these problems, right, to kind of show that you're getting it. If you're really not sure still, kind of put a question mark up here. Okay, so you should have one of these two on your paper right now, showing your understanding so far of this. Now when we talk about pressure, a lot of times we want to talk about air pressure or water pressure. It's one of the more common ways we'll hear about pressure. We can talk about the pressure in our tires too, and all those things are measurements of things under pressure. Air pressure in particular is something that will decrease as we go up in altitude. If you could look above you and actually see the air above you, and you can if there's some clouds up there and you're outside, as you go up through the atmosphere, there is less and less amount of air above you. So you can see in this picture here, there's a lot more air down here. Why is that? Well, that's gravity. Gravity's pulling all of this air down, and it's much more dense. There's a lot more of it together down here than up here. Because of that, as the air gets thinner up here, we have less air pressure. There's less air pushing on you. You can imagine all this air up here is pushing down on you right now, but it's on all sides, so it's equal. A similar thing happens underwater. As you go deeper underwater, that water pressure will increase. Right? You'll get more and more water pressure because there's more and more water above you, and pushing in on you. So what types of things happen as air pressure changes? One of the ways we experience this in everyday life is when our ears pop. And that happens different times when we go up a mountain or down a mountain. If you've ever been on an airplane, you felt this change in pressure. And sometimes even when the weather changes, you'll have a change in pressure and you can feel it. And we only notice air pressure then when it changes, and that's the popping in our ears. If you notice in this picture here, the difference in the inside and the outside of our ears. This is our outer ear. Here's our eardrum and the middle ear here. And we have a tube here that goes down to our mouths, and this is what we can use to equalize the pressure. Okay? If we go up a mountain, suddenly there's more air inside, there's less air outside. Remember, there's less air when we go up a mountain. There's less air pressure. So notice this is a lower number. This is a greater number. These are unequal. And we know what happens when it's unequal, right? We caused motion. This is moving this way. There's more force pushing out this way for this same area. And this is what we feel as, pain sometimes. To equalize it, this tube has to open up and let air in or out to equalize that pressure. So now we have the same pressure inside and out. Another way we might experience this is as a balloon goes up in the atmosphere, it increases in size as the gases in the balloon expand. This is actually what Pascal, the scientist, did when experimenting with this. He took a balloon up a mountain and saw that it got bigger. And if you were to take a balloon underwater, you would notice it gets smaller due to the pressure. So there's less pressure on the outside of a balloon. So if there's less air, right, this is my balloon here, if there's less air on the outside of it, that air on the inside wants to expand and take the place of that air that's missing out here. So as that air disappears, the air inside will expand, causing that balloon to get bigger. Knowing this, why should you put toiletries and other expandable items in a plastic bag when flying? What might happen if you get in an airplane and it's not pressurized properly and you have your toiletries not in a plastic bag? Think about it and write an answer. Lastly, in class, we're going to look at something called a vacuum chamber. And a vacuum chamber is cool because we can simulate, we can kind of make it look like we're gaining altitude, we're going up a mountain or up in the sky. By removing air from this chamber, a vacuum means the lack of matter. Right, so we're going to suck all the air, or most of the air out of the chamber, and we're going to see what happens as we go up a mountain and we create a vacuum. Okay, now that you're done, take a moment and write the words, or the letters done, down here. And you can put an exclamation point just to show that you got through this whole thing and you're finally finished. Okay?